this is Nat Maven. Today we're gonna make a lab about the Cisco NAT Nexus dashboard fabric controller for VXLAN with a Super Spine. I will use Nexus dashboard fabric controller to create and provision a new Greenfield VXLAN EVPN 3-tier fabric with a Super Spine switches. Just look at my diagram. We're going to create and configure the VRFs and the networks within a VXLAN EVPN fabric, and I create a new external fabric also. Lastly, I create inter-fabric connection between the VXLAN EVPN fabric and the external site. First, allow me to tell you what is NDFC. NDFC stands for Cisco Nexus Dashboard Fabric Controller. If you're new to this, it offers a network management system that supports traditional or multiple tenant LAN and SAN fabric in a single window. This NDFC works across all Cisco Nexus and MDS switches families. It manages the large numbers of devices. We're providing a ready-to-use control and management and automation capabilities, including the VXLAN. It takes control and automation for the Cisco Nexus LAN fabrics. It supports also automatic configuration for the multi-tenant automation. I have videos about that. Please just search my old video. It offers integrity and storage virtualization, providing and troubleshooting. Of course, you can see this in an intuitive multi-fabric topology view for the LAN fabric and storage. The first time you start the NDFC from the Cisco Nexus dashboard controller, NDFC will show what you have is the feature management screen. It is under my virtual management and the setting and the feature management. If you don't configure the installer or features at this point, the NDFC feature management will only perform the backup and storage operation. So we're going to enable this feature later. What I have to choose is the fabric controller. Select the fabric management option in the setting here. Of course, in here we already enabled it, and I don't need to configure the feature again, but you still need to see the feature management screen right here. But next, let me talk about what is VXLAN. VXLAN stands for Virtual Extensible LAN. It is an overlay technology for network virtualization. It provides a layer 2 extension over a shared layer 3 underlay infrastructure network by using the MAC in IP UDP user datagram protocol tunnel encapsulation. So the reason to obtain a layer 2 extension in an overlay network is to overcome the limitations of the physical server racks and the geographical location boundary to achieve a flexibility for placing the workload within the data center or different data center. But next, there is initial IETF VXLAN standard RFC 7348, which defines a multicast-based floods and alarm VXLAN without a control plane. So it relies on data-based flood and alarm behavior to remote VXLAN tunnel endpoints, which is the VTAPs. The VTAP peer discovery and remote end-host learning is in the overlay broadcast unknown unicast, and the multicast bomb traffic is encapsulated in multicast VXLAN packets. It is transported to remote VTAP switches through the underlay multicast forwarding. So the flooding is in such deployments shows a large challenge for the solution, and the requirements to enable the multicast capabilities in the underlay network also presents a challenge, because some organizations do not want to enable multicast in their data centers or WAN network. So take a look at this diagram. It's to overcome the limitation of the flood and learn VXLAN as defined in RFC 7348. Organizations can use multi-protocol border gateway protocol, what is MP-BGP, Ethernet Virtual Private Network, called EVPN, as the control plane for VXLAN. So IETF defines the MP-BGP EVPN as a standards-based control plane for VXLAN overlays. The MP-BGP EVPN control plane provides protocol-based VTAP peer discovery and a host reachability information distribution that allows more scalable VXLAN overlay network designs suitable for private or public cloud. The MP-BGP EVPN control plane will introduce a set of features that eliminates the traffic flooding in overlay network and enables optimal forwarding for both east-west or north-south traffic. Now we talk about where use the Super Spine. So what is Super Spine is a device that is used to interconnect multiple spine and leaf pods. There are two options to configure the Super Spine switches using NDFC. What you see here is our Super Spine 1 and Super Spine 2. You can have multiple leaf and spine pods between same easy fabric that are interconnected through the super spine, so the same IGP domain extends across all the pods, including the super spines. What you see here is going to be the two pods, the pod 1, the pod 2. Within such deployments, I provision a BGP RR or RP on the super spine layer. The super spine layer the spine layer become a pseudo interconnect between the leaf and super spine. So optionally, super spine can host VTAPs if they have a border functionalities. Like here, we have external fabric also. And take a look at this diagram. What I have is a two fabric, DC1 and DC2. I use a super spine here to interconnect multiple VXLAN EVPN easy fabric using the super spine. So these super spines will have a multiple super spine, maybe here, they can connect here also. Like this diagram, what do we have? Super spine, a lot of super spine, 16 super spine, 8 spine each data center. Within the easy fabric, I can use appropriate IGP that has its own IGP inside for underlay connectivity, and what I have is eBGP between the super spine, eBGP between the super spines. In the external fabric, it's gonna also become an external fabric. And the super spine in the easy fabric is recommended way of interconnecting multiple VXLAN easy fabric. Or maybe I have here's DC3. I could connect it to here, DC4. I connect to my Super Spine fabric. I will configure the eBGP peering through the interconnect, inter-fabric links, or appropriate mix of interface and eBGP configuration on the respective switches. So the NDFC also supports the Super Spine roles. Let's leave the external fabric. One type of border Super Spine is called border Super Spine. A border Super Spine handles multiple functions, including the Super Spine, and we have RR, we talk about it, RP, and or it can be a border leaf. Similarly, a border gateway Super Spine serves a Super Spine, RRRP, and a border gateway also. What is a border gateway Super Spine? Border gateway Super Spine is nodes that interact with the nodes within a site, or with nodes that are external to the site. For example, in the leaf spine data center, it can be leaf, it can be spine, or it can separate device acting as a gateway to interconnect the sites. In here we have is a 3-tier leaf spine topology with a super spine is an example of a scalable data center design. Tier 1 consists of my leaf switches. That connect to the servers, right? Is here the server. And the tier 2 consists of fully matched spine switches connecting to the leaf switch in this layer. The tier 1 and tier 2 compress our server part. The capability of each server part, that is the maximum of the server per server part, depends on the choice of tier 1 and tier 2 switch. And the tier 3 consists of the super spine switches, which interconnect the server parts in here. The tier 2 spine switches in each server part are fully meshed, connecting to the tier 3 spine switch. With the 3-tiered spine leaf design, to scale the number of servers, I add more server parts, and to scale the bandwidth interconnecting the server parts, I add more and more super spines. The maximum number of the server parts in this design can be supporting depends on the super spine switches capacity right here. So for example, is this 100 gig uplink. In each part is a 100 gig uplink, and we have a port 1, port 2, like with connecting with multiple parts with a super spine like this. First, let's verify the server's IP address and connectivity. This lab contains 3 servers that are connected to the fabric through different leaves. First, my server 1 connects to leaf 1, my server 2 connects to leaf 2, server 3 connects to leaf 3. So each one will have its own IP address. We have just verify it. Server 1, I tap ipconfig. I can verify the Ethernet 1 IP right here. And to verify the connectivity from server 1, we're going to ping 10.10.10.11 to server 2. and it's 100% packet loss, and we would like to ping 10.10.11.11. we would like to ping it to the server 3, and is also show not ping is not successful, and there's 100% packet loss. And we want to ping the 8.8.8 internet. Stop the ping. I don't have the connectivity. The goal is to have the connectivity working between the servers and external resources at the end of the lab. Now we are going to work on it, and in the manual we're going to go to the fabric controller. In the LAN and the fabric, click the fabric. We're going to create a fabric. The fabric name we'll be creating is VXLAN EVPN Greenfield Site 1. And then we're gonna choose a template. We choose Easy Fabric. In the general parameter, in the AS number, we'll just give it AS number 65001. And click the advanced. Notice that the site ID will say 65001, and we'll scroll to the green field cleanup option here. We want to clean up. Okay, and let's go to the top. Navigate to configuration backup. We would like to use Huawei Fabric backup. And lastly, click the save. We're creating a fabric. Let's open the fabric detail. We're going to the switches. We're adding the switch, and I assign the role to each switch. In the preserve configuration, we are going to uncheck because it's Greenfield. Let's click discover switches. Here you go, we're going to select everything except the external router. Add a switch. When the import completes, the status is going to show the status. They show the complete, and we're going to add a switch. I will pause my video right here and until they all showing manageable, being complete. Still in progress. Now the switches are added. I'm going to assign the role to my spine leaf because they're all showing a leaf role. Set a role. Here we're going to select the spine. Select it. Click OK. And next to the Super Spine 1 and Super Spine 2, we'll set a new role for them. The role we're gonna show is the border gateway Super Spine. Select it. Here you go. Now I'm showing 2 spine and 2 border gateway Super Spine as what we have here. Border gateway Super Spine. This 2 will be my spine. Leaf. Alright, we have alarmed multiple times to recalculate the configuration. So actually with this time we'll do it. We'll have to recalculate configuration and deploy. Let's to review the configuration. We can tap the lines pending to be pushed, and we click deploy. Let's close this pop-up window. In the switches, we can see leaf spine and super spines. Next, we will configure access interfaces to the servers. In the fabric overview, we're gonna click the interfaces. That's filter the device for my leaf one, and interface will be Ethernet 1/2. How do I do that? In the filter here, where I say device name equals to leaf-1. Now we have the all interface on leaf 1, and this time we are going to filter the Ethernet interface 1/2. What I want is to edit this interface. First, in the policy, we're going to select the access interface access host, and in the VLAN access VLAN here, we want to use 230. Here you go. And let's save the config and click deploy. The expected config here I have is all the interface, and I assign the VLAN 230. Click deploy the configuration. Next, I will tell you is to filter the leaf 2 on Ethernet 1/2, and here we're gonna to assign the same VLAN 230 as in the same subnet. Doesn't matter. Then on leaf 3, we want to assign to the VLAN 231. We'll repeat the previous steps on these interfaces of different leaves 2 and 3. Alright, let's close this window. We're gonna filter the other device. That's my leaf-2. The interface 1/2. I've select this interface and add it to use the policy interface access host. In the VLAN, I choose 230, save it, and we'll have to deploy. Alright, close the window. We'll repeat this to device equals leaf 3. Same interface number. Two, 3, 1. Save it, deploy. Deploy this. Alright, for the next section, we're gonna show you how to create the VRF and networks. We would like to go to create the VRF, navigate to VRFs, and here, let's create a new VRF. VRF the name, we'll use the my lab VRF. VRF ID. We don't want to change it, but VLAN ID we could assign to 2000, and we'll click create. So basically what we're doing here, we're creating the VRF. The whole fabric is a VRF 50,000. And it has a VLAN to map out. we're creating the L3 VNI. Alright, let's click the create. We create a VF, we'll create a network, navigate to network, and we're going to create. What creating the network is the network lab underscore net 10. VF name only have one VF and it's being chosen. And network ID 30,000. VLAN we use 2300. That's my L2 VNI. IPv4 gateway, we're going to choose 10.10.10.1/24. That's my multicast anycast gateway. Okay, let's click create. We wanted to create other. That's lab net 11 2301. The mask 10.10.11.1/24. Create. We're creating two VNI network, L2 network. So in here we create a VRF. That's L3, right? The name is lab. Under it, we created net 1. The VNID, that's 30,000. And VLAN, we manpower 2300, 2300. Net 2, VNI is 30001. And VLAN 2301. That's L2 VNI, L2 VNI. Remember this? So we have created the VRF networks. We want to attach we associate the network to a VRF, and we wanted to attach the network after creating the network. So go to the network and under network 10, and we want to add it. Sorry, let's close this. Under here, there's another tab called network attachment. We will going to find out the leave one, and we wanted to attach the network 10. So that's network name equals net lab underscore net 10. We'll see all the switch. I have the leave switch, want attached to leave 1. So to do that, we wanted to attach, click it attach, and note that I will attach to where? Ethernet 1/2. That's my net 1. I can attach this. Save it, attach, and this showing pending. The same job we have to do, you know that we have to attach again net lab, the lab underscore net 10 to where? To another leaf 2. We wanted to attach to leaf 2 Ethernet 1/2. That's going to be net 10, sorry. Net 10. Net 11. Net 10. Okay. Net 10, we'll find out leaf 2 and we want to attach to the interface. Attach to my Ethernet 1/2. Save that. Now, again, lab net 11 leaf 3, add it, attach to that same interface. We're attaching net 11. All right, we made attachment. Now we're going to recalculate the device. See how we're seeing leaf 1, leaf 2, leaf 3 are out of a sync, and we're seeing 63 lines are pending to be configured. What we're going to configure, we're configuring is the L2, L3 VRF, and L3 VNIs. Also, you'll see the BGP were configured. Okay, it's an MP-BGP. Deploy this. After deployment, I will show you very intuitive fabric topology connectivity. Now, deployment completed. I close this and we navigate to topology. Click this fabric sites. Here you go. Let's change the view to configuration. We can hover over to the links, hover to the switches to see the status. To see where I deployed an object, we could do this network, click network, or the VRF. Want to see where I deployed net 10 VNI? Here you go. I'm showing leaf 1 and leaf 2. Where deployed net 11, leaf 3. Now back to my server 1. If I have the server 1 here and I would like to ping server 2 and want to ping server 3, can I ping that? Or I can ping loopback internet 8.8.8. Can I still do that? Let me do it. Ping 10.10.10.11 to server 2. Yes. Let me ping server 3. That's yes. And ping the internet. No. So the result is I could not ping external, but I could ping the internal different VNIs because they are under the same L3 VNI, same VRF would be routed to it. Okay. So in overall, connect server between ping between the server now is working, and connectivity to the external sources 8.8 LDA still fails. So this on my next lab, we're gonna to create and configure the VXLAN external fabric, which is this fabric. We'll see you in the next video. Thank you for watching.